Polaris Industries LP presents Snowmobile Service Topics 1993. Contents of this video include front-end alignment, electronic fuel injection, engines, fuel delivery, and carburation.
In order to quickly and effectively align a Polaris Indy front end, first be sure that the track is adjusted and aligned properly. Refer to the track and drive section in the Master Repair Manual. Elevate the front of the machine. Remove the ski bolts, the skis, and remove the pivot bushings. Measure spindle centering to the chassis from each side to be sure that they are equal. Then measure total spindle width from center to center. Standard front ends should measure approximately 36.5 inches, while SP type front ends are approximately 38 inches wide. These major adjustments are normally required only after a front end rebuild and are easily performed before the nose pan would be reinstalled. Next, insert the alignment bar. If the alignment bar cannot be inserted, adjust the tie rod ends or the lower radius rods until the bar slides through easily from each end. It is important to start the alignment bar through each side to enable the technician to adjust each spindle equally. Always remember to adjust the spindle that the bar is located in at that time. If you have to lift up slightly to insert the alignment bar, that's acceptable. Slight off camber is allowable as shown here. Once the alignment bar is in place, with the drag link removed, center the main steering arm by turning both tie rod ends at the same time. Then center the handlebars by turning the drag link either in or out. Next, inspect each outer steering arm. These arms should be parallel to slightly inward, following along each trailing arm. If these arms do not line up, remove the pinch bolts, re-index the arm on the spline on the spindle. Once these steps have been completed, camber is now set along with preliminary tow out. Next, remove the alignment bar, lubricate the pivot bushings, reinstall them. Reinstall the skis. After ski installation, always remember to use a new cotter pin in the ski castle nut. By laying a straight edge along the track and skis, final tow out can now be adjusted. To remove any play in any of the steering components that might remain, attach a bungee cord or rubber strap to the ski loops to help hold the skis together. Be sure that the handlebars are still centered. Measure from the ski to the straight edge in front and in back of the spindle. We recommend a minimum 1/8 inch toe out. Repeat this for the other side. Turn the handlebar fully one way and adjust the steering stop. Repeat this for the opposite side. Be certain that all fasteners have been retorqued to their proper specifications as the final step. New for 1993 is the adjustable torsion bar, which comes as standard equipment on the XCR and is available in kit form for other Indy models. Part number is shown here. For high performance applications, this torsion bar can be adjusted for any number of varying conditions and rider preference. Each side is individually adjustable by either lengthening or shortening the tie rod ends. Very little maintenance is required. However, periodic inspection of this aluminum support area, the set screws, and the mounting rivets is required to prevent loosening. One other item to keep in mind, very important that the bar arm pinch bolts are kept tight to prevent arm to spline loosening. Periodic lubrication of the bushing and the shaft area is required. Use Polaris low temp grease for this application. To check for correct rod end adjustment, there should be a small amount of free play in each tie rod end, with the rider seated on the machine. Again, to accomplish this, either lengthen or shorten each tie rod end, tighten the jam nut. The bar arms should also be parallel with the rest of the machine.
In this presentation, we will cover changes made to the 1993 EFI 500. Some of these changes include a new method now used to power up the EFI system, the MR control screw adjustment and the effect that it now has on startup. We will also cover throttle sensor testing, troubleshooting, and other important tips. This videotape should be used in conjunction with the Master Repair Manual EFI section. Reference should also be made to the 1992 service tape EFI section. Select monitor hookup. Find the service plug located in the harness. Push the lock tab and plug inward to release it from its protective cap. Locate the short select monitor adapter harness and plug it into the service plug. Install the select monitor service harness and cartridge as will be shown. For 1993, the method for powering up the EFI system has changed. 1992 models required that we turn the ignition key to a spring-loaded start position. This start position would power up the EFI unit and turn on a green ready light. This year's EFI 500s do not have the ready light or spring-loaded key switch. To power up the 1993 system, we turn the select monitor switch on, turn the key switch on, turn the auxiliary kill switch on, and pull the recoil rope. This procedure activates the EFI system and the select monitor. The cartridge has not been reprogrammed for 1993, and the model year display will be inaccurate. If the engine is warm, the length of time that the EFI system and select monitor stays powered up is limited. If long testing times are required, it will be necessary to install a jumper wire into a harness connector located behind the console. The short jumper is placed between the yellow-green and red-yellow wires. This will allow the ECU and select monitor to be powered up for longer periods of time. This 5-pin connector is also used for adding electric start to the 93 500 EFI. The 1993 EFI 500s will also use a different protective device for the wire harness. Previous to 1993, we used a fusible link or wire. Now we will use a self-setting 12-amp circuit breaker. This circuit breaker is on the battery support bracket. Also located in this area is the ACS, or alternator controlled sensor. This sensor is located to the inside of the support bracket and held in position by these two bolts. Shown is the ACS module as seen when removed from the vehicle. The center two wires, gray and gray-white, are connected to the battery charge coil. The module changes the alternating AC current from the charge coil to direct current. DC current travels through the red wire and is used for battery charging. The orange wire located to the left side of this module sends an alternator signal to the ECU through an orange-black wire. This signals the EFI system to power up. The 1993 500 EFI will no longer use the crankcase temperature sensor. When using the monitor, disregard the readings found as you pass through this function. The startup relay and fuel pump relay have also been relocated to the top rear side of the ECU and are positioned as shown. This new location and these new relays will provide better protection against moisture. For 1993, the MR control screw or mixture enrichment screw will no longer have a significant effect on the amount of fuel delivered during idle on a warm engine. It will, however, have a noticeable effect on the amount of fuel delivered to the engine during startup and cold drive-away. If a richer startup or drive-away is needed, the numbers on the MR screw should be increased. If a leaner startup or drive-away is desired, the MR control screw setting or numbers should be decreased. Normal settings will be between 2 and 3 on the MR control screw and should provide good startup and drive-away. Shown is the throttle position sensor. This sensor is located on the right side of the magneto side throttle body and attached to the throttle butterfly shaft. When the throttle is opened and closed, a wiper inside the sensor changes voltage readings seen by the ECU. Throttle position sensors can and have failed. They must be tested and adjusted by using the select monitor. The select monitor, when adjusted to mode FO4 as shown, converts the voltage readings from the ECU to degrees of throttle valve opening. These numbers represent actual butterfly angles. When troubleshooting the throttle position sensor, it's important to position the select monitor in mode FO4 and slowly increase the throttle settings. The numbers shown must increase progressively as the throttle is opened. Large changes in these numbers with small movement to the throttle indicate throttle position sensor is defective. These numbers should also progressively decrease as the throttle valve angle is changed from wide open to idle. Squeeze the throttle open slowly and close it slowly while viewing the select monitor. And remember, big changes indicate a defective throttle position sensor. In mode F14, the select monitor again reads throttle valve angles in degrees of opening. However, in this mode, it breaks the degrees of opening into smaller movements and therefore provides a more accurate reading. Use this position for readings of 0.1 to 35.9. Mode F14 is used to adjust the throttle position sensor. The throttle position sensor is adjusted only when the butterfly is completely closed. To ensure the butterfly is closed, proceed as follows. Back out the idle stop screw. It may have to be turned 4 to 6 revolutions. Remove the throttle cable from the throttle flipper and snap the throttle cable a few times to ensure the butterflies are completely closed. If adjustment is needed, loosen the 2 screws that secure the throttle position sensor to the throttle body and rotate the position sensor so it reads 0.1 degrees opening. It's important to adjust to 0.1 degrees opening as the select monitor will not read in degrees less than 0. Adjusting to less than 0.1 degrees may cause light throttle lean conditions resulting in drive-away problems and overheated pistons. After the throttle sensor is adjusted, rotate the idle stop screw inward until you see 3.4 degrees opening. This will be relatively close to the correct degree of opening to maintain idle RPMs. However, idle RPM must be adjusted after the engine is started and warmed up. One of the last modes or check positions on the select monitor is the startup circuits or key circuits. In this mode, the ST correlates to the number 1 LED light. This indicates the ECU is seeing a signal from the battery to hold the start relay in. The KY and corresponding number 5 LED light indicate the jumper wire has been installed at the 5-pin connector and that this circuit between the battery and the ECU are complete. The DM and corresponding number 6 LED light indicate that the dealer mode wires have been connected and the circuit is complete. Use these tests if needed. If servicing an EFI system and it becomes necessary to loosen or remove any fuel lines, it is very important to isolate the fuel pump so it cannot run. Fuel pumps can cycle with very little movement to the crankshaft, and while running with an open line can move significant amounts of fuel and create a hazardous situation. This concludes our update on the 1993 EFI systems. Thank you for your attention.
In this part, we will be reconditioning a cylinder. The tools required for this operation are a low-speed drill motor, a bar-type cylinder hone, honing oil, a feeler gauge for measuring, and hot soapy water to wash the cylinder when the operation is done. Mount the cylinder in a vise and insert the hone into the bottom first and tension it by hand so that it doesn't get too tight. Install the low-speed drill motor and add honing oil to the hone and cylinder bore to keep material from galling or balling up on the honing stones. Move the hone slowly in and out to create a nice crosshatch pattern that is required for long ring life. A bar type hone, when used properly, will actually take slight distortion from the cylinder that has been created by heat stress, by heating the engine, cooling, and heating it up again. The bar type hone will pretty much true up the cylinder for good piston and ring life, and I might add for performance. We reverse the cylinder and we'll hone it from the top down, and this creates a nice port entry for the ring from both directions. After honing, wash the cylinder in hot, soapy water to release any particles left on the cylinder during the honing process. Hot soapy water is the recommended method of cleaning the cylinder other than Stenosol or gasoline. Observe the crosshatch pattern that is required for good ring life. Next, we have to check piston size to the cylinder bore to see if it is necessary to continue honing or if it would require boring to oversize. We're simply using a feeler gauge for this operation. After you have determined that the bore size is okay, it is necessary to chamfer the port edges to get a nice radius of the port using a small chainsaw file, or this tool is a port chamfering tool, and it is necessary to chamfer all ports, including the small transfer ports. Again, clean all of the deburring material out of the cylinder before reassembly. Last but not least, oil the cylinder with injector oil to combat rust buildup, which happens very quickly on a cast iron sleeve. The cylinder actually will rust in just minutes. It starts to be a dusting of rust, which the oil will retard. Next, we will check ring end gap. Position the ring in the cylinder. Use the piston to center the ring approximately 1/2 inch down from the top of the bore, as this is where the ring travels during operation. 6 to 18 thousandths of an inch is the spec used on all Polaris engines. EC58 PL engine tips for reassembly are as follows. It is required to install some 515 on the PTO and mag end of the crankcase base gasket as shown. This is a new engine and requires a procedure for reassembly that has previously been not needed on Polaris engines. We are using a monoblock, and the pistons must be as shown for easier cylinder installation. The piston ring end gaps must be centered on the anti-rotation pins. Start on the mag side first. Collapse the rings with your fingers. Twist the cylinder back and forth slightly and easily, carefully, so that it does not damage a ring end. Then move to the center cylinder. And over to the PTO end. Remove the wood block. Tighten the crankcase nuts, and next install some 515 around the O-ring area of the combustion chamber. These rubber O-rings replace the previously used lead gaskets that we are all familiar with on prior year motors. The water outlet holes of the head must be positioned on the PTO end of the motor. Install the head and torque following the torquing procedure in section 5. Apply 515 Loctite to the water cover as shown. This is the spark plug area. Next, install the backup washer into the previously applied Loctite, and then install the O-ring as shown on all 3 spark plug areas. Inspect the outer O-ring gasket. Make sure it's in its proper groove for reassembly, and then tighten the water cover to the head. When truing a crankshaft, it is necessary to have the proper equipment. You must first have a good holding fixture to hold the crankshaft. Then it is necessary to have either 1 or 2 dial indicators for checking crankshaft runout. You must also have a 1/2-inch adapter for spreading the crank. You must also have a modified bolt cutter for pinching the crankshaft and a brass hammer for striking the crankshaft wheel to turn it on the rod pin. Whenever you are straightening a multi-cylinder crankshaft, you should always start on the PTO side and work your way toward the magneto side, straightening 1 crank rod pin at a time. The dial indicator position in relation to the rod pin tells what action is required to straighten the shaft. The crankshaft in this position shows that the high part of the crankshaft is with the rod pin 90 degrees from the dial indicator. It will be necessary to remove the crankshaft from the fixture and strike the crank wheel where the above arrow or top arrow indicates. Using a brass hammer, hit the crankshaft wheel 90 degrees from the pin. In this case, the dial indicator shows that the high part of the crankshaft is with the rod pin in the up position. The inner dial indicator on the bearing shows approximately 2 thousandths, and the outer indicator shows approximately 5. This indicates that the crankshaft will have to be pinched directly opposite of the rod pin to bring the end of the crankshaft down. You are actually just moving the crank wheel on the pin. This operation can be done with the crank in the fixture. In this position, the dial indicators are showing that the high part of the crankshaft is with the rod positioned in the down position. The inside dial indicator shows about 1.5 thousandths, and the outside end of the shaft being almost 5. This will require that the crankshaft be spread with the 1/2-inch adapter. We are using the adapter method instead of the wedge, as we feel the wedge method is just a little bit too abrupt. The adapter method is just an easier one, and it's a lot easier on the shaft. Again, you must remember that the dial indicator in relation to the rod pin tells you the action required necessary to straighten the crankshaft. Next, make sure the crankcase is in good shape before reassembly. This is done by inspecting the bearing journals in the case. Some crankcases have steel inserts around the exterior of the bearing. Some are just aluminum. This shows a crankcase that the bearing has been chattering in, possibly because the crankshaft was crooked. And way to check for a good quality case is to simply insert a bearing into the journal area. Press it in, and it should snap in and stay there. This shows that the case is worn enough that the bearing will fall right out of the case. We'll move over to a good journal and show the proper bearing fit. With just a slight pressure, you should be able to tip the case completely upside down, and the bearing should stay in. Polaris has different tolerance bearings. We call them C3 or C4 in the Polaris engine. They do have different crush tolerances. If you run into a crankcase that has journals that look like this, the crankcase should be replaced.
When carburetor diagnosis becomes necessary, other parts of the fuel delivery system should be checked carefully before any major disassembly is performed. We'll begin by looking at the fuel tank outlet and in-tank fuel pickup hose indexing. This cutaway is a representative of what can happen inside the fuel tank if the outlet fitting is threaded into the wrong position. A simple visual inspection through the fuel filler neck will tell you if the hose and the pickup are in proper place. In other words, the pickup and hose should be laying on the bottom of the tank. Next, check the fuel tank vent line for proper routing. Look for any kinks, pinched areas, possible obstructions in the end of the hose. To inspect the fuel line, follow it from the outlet to the shutoff valve. Then from the shutoff valve to the filter, the fuel filter to the fuel pump. Look for any trouble spots, loose clamps, leaky hoses, kinks, or obstructions. Next, slide the clamp back, remove the fuel pump impulse hose. You can connect a mighty vac and apply some pressure. 5 to 7 pounds is enough. This will tell you if the diaphragm is okay. And again, be sure the hose is not kinked or pinched. The carb float bowl vent line should be free of kinks, routed to the handlebar area correctly, as explained in the Master Repair Manual. There are check valves located at the bottom of these vent lines. They can be checked for proper operation with the Mighty Vac by applying some pressure. First in one direction, then reverse the valve and try to apply pressure again. If the valves are operating correctly, they will hold pressure in one direction only, allowing fuel to drain out of the carburetors, but not allowing pressurized air to enter the vent line into the float chamber. Another important pressure test is carburetor needle and seat or float valve condition. Anytime a carburetor disassembly or cleaning has been done, just invert the carburetor, apply pressure to the fuel inlet fitting. With just the weight of the floats on the valve, the gauge should hold approximately 2 to 5 pounds for a minute or so. On engines equipped with 38 millimeter carburetors, vacuum fittings are provided for use of mercury manometers or vacuum gauges. In order to synchronize carburetors, we will be using the mercury manometers here. Machine preparation will remain the same as with the Unisync gauge. Follow the instructions in the service manual to prepare the machine. Remove the vacuum fitting rubber caps from each carburetor and install the mercury lines. Try to keep the board upright at all times to avoid mercury spillage or ingestion into the engine. Start the engine, allow it to warm up, and for the idle to stabilize. A high mercury column indicates high vacuum or a low throttle slide. Adjust each idle screw until the columns of mercury are equal in height. Now refer to the service manual for the correct idle RPM on the model you are working on. Apply slight thumb pressure to the throttle. Turn the cable adjusters until the columns of mercury are again equal. After this is done, recheck throttle lever free play. Throttle free play, when completed, you must be between 10 and 30 thousandths of an inch. If any adjustment is required, both cable adjusters must be turned in an equal amount. Choke cables should be adjusted so there is approximately 1/4 of an inch free play at the lever end. This should be performed before any other adjustments are made to avoid idle mixture problems. Turn each cable adjuster until the correct free play is obtained. As a final step, verify oil pump synchronization. The pump lever index mark must line up with the pump housing mark at idle position. Turn the oil pump cable adjuster until the marks line up. Don't forget to retighten all your lock nuts.
Thank you for viewing Part 1 of Snowmobile Service Topics 1993. Please proceed to Part 2.